Good day, class. How was your weekend? Alright. So, who are assigned today for our opening prayer? Who is the prayer leader today? Amen. Do you still remember my house rule number 3? Kindly pick up the pieces of paper if there's any and arrange your chairs and tables properly, right? I thought that you forgot that, but you all didn't. And keep it up. I just want you to know how to be clean, right? And that is for the good of you all. So, Dad, to have a comfortable place before we start our class. So I'll give you 2 to 3 minutes for that. Okay? Okay. It's already time, so sit down now and I'll be checking your attendance. If I call your full name, then say a thing that involves matter, alright? For example, Crisbel Sigara, and you said chalk. So I started from the boys. Did you get it? Okay, here's the list for the male students. So Jamon B. Cabarubias. Okay. And Zyle Kenneth M. Lim. Okay. James Kurth L. Susan. And for the female student, Axin Jane B. Cruz. Okay. Kristen Lynn O. Javier. Jai Shane R. Lumenis. Is everyone cold? Alright, so no one is absent right now, and that's good that you all are here. And give some applause each one for yourself. Yeah. And what have you seen all these stuffs in the blackboard? Try to observe the things that I have been put there, and can you name all of these? That's correct! This is a structure of a melted ice cream, right? And a sublime naphthalene ball, right? Do you know naphthalene? Those white ball? I guess you have seen already. Alright, that's good. And the last picture is an air balloons, right? That's right. Okay, so as you look at this picture, class, there is a change that is happening, right? Am I right? So the picture A turns out different from picture B. Am I right? Exactly. So that's it, what we call the changes that materials undergo. And this is our lesson for today. And I am going to discuss right now again what is the topic all about. Correct! Our topic is connected from the past discussion, which is about matter. And since we already know the properties of matter consists of 3 parts, the solid, the liquid, and the gas, right? Each of these existing properties can break through into 4 classifications of changes of matter, such as from solid to liquid, from liquid to gas, from liquid to solid, and lastly, from solid to gas. Alright, so remember, each properties of matter has its own details about the particles. So let's first tackle this one. And for solid, has a particles that is very close to to each other. Therefore, their movements are limited because of they are very close to one another. That is why solid has a rigid and compact appearance. And for liquid, has the particles that are arranged far apart from each other, unlike the solid. And you cannot see any space beside the particles, right, class? The particles of this liquid portion can glide or slide around from one another. This is intended that liquid takes on the shape of the container. As you look at these three in liquid, it occupies all the space of the container, right? Alright. And you can see how it's shaped according of it towards the container. Last but not the least is the gas. So the particles lie very far from each other. Why the particles lie? If you mind me asking to all of you, why the particles lie? Because as you look at this container in the blackboard, have you seen? All the particles are distant from each other, right? So that is why the particles of gas moves faster. Yes. And that is why the particles eventually lie from one another. In conclusion, when particles are far from each other, the weaker the force is. On the other hand, the closer the particles, the stronger the force is. So let's move forward now. In connection to that arrangement of particles, we have here 4 classifications how we tend to the change of state towards the materials. Just like what I have said earlier, right? So we have here from solid to liquid. So the best example for that is the melted ice cream, right? As you look at this picture, or based on the experience we had, what is the reason why ice cream melts? Because of the heat. The heat energy is always present when it comes to changes of matter. Remember that. The solid material there is melting. So the word there is melting. Melting. And the particles of solid became liquefied. When we say liquefy, it liquids. Because they move farther, turns out into liquid. That's it. This change called melting. That is the term when the change of state from solid to liquid. Get it, class? Alright, good. So the next one is from liquid to gas. So we have here 4 categories. And the best example here is the water. We all know water, right? It is something unliquid. Just like the ice cream melts, it resulted into melting. In that setup, the particles of that water or to that melted ice cream move faster and more rapidly farther apart. This time, the particles allow to escape. So, we have here vaporization, called vaporization. This is where the vaporization comes out when the liquid water becomes to change to a gas, or we called it water vapor, right? Alright, thus vaporization takes its place through the gain enough energy of liquid in order to move and forms into gas. Get it? Alright, so for boiling, we have here also boiling, the word boiling. When the more added heat energy or the heat temperature increases, of course, the liquid here still continue to boil, just like when we boil water, right? Or have you seen your parents when she wants a coffee or you're offered by your parent a milk? When you boil the water, of course, there is a pressure of heat there. And the temperature will increasingly go high up. And that is the time the boiling created when there is a rapid change because of the temperature. And that's we call boiling. And for the third one, or the third word, is evaporation. When we hear this word, this is usually occurs in the surface of the liquid. Of course, in this time, remember the particles of liquid here moves quicker than the particles of a strong force in solid. So remember the rule of the three properties of matter. It has a potential to be visible, means go away or to disappear or vanish. Right? Sa Bisaya pa mawala. So, when we talk about evaporation. Get it? Okay. And next, we have here condensation. This change of state is from gas to liquid. It is a counterclockwise of vaporization. If you mind asking me right now, if the two are opposite, what makes it similar or related to each other? So here's the thing, class. I just want to explain it to you in a simple manner. When we talk about boiling, it's the part of heat energy, which is hot. While in condensation, it talks about cold environment. So there is a situation when the heat surface is releases from the cold surface. Then the particles that make up the gas begin to slow down and move closer together. The cycle here is the gas changes into liquid again, and that's the condensation formed. In short, condensation is from a cool surface or in cold environment, and the change of state is from gas to liquid, and never the same with boiling. Are you still there? Or is it a change? A person change, not the material one? Are you excited from your dismissal, right? So, here we go. Let's continue and move forward. We still have the last two to end our discussion. Alright, so we go now from liquid to solid. So move forward from liquid to solid. When is the situation takes place for this? Here at the best scenario, we can still use the example of a melted ice cream. Then we send it into a refrigerator. And what will happen next? What do you think the result of this? It will freeze, right? Impressive. Just like when you sail on ice, right? Water has a condition of liquid, and when it becomes an ice, then it becomes solid. Obviously, so in that matter, the change of state is what we call freezing. So the word is freezing. Get it, class? Yes, it's easy to remember, right? Yes, I get you. So, the last but not the least, from solid to gas. Oh, are you shocked? Yes, did you hear it right? We are now from the last row. The best example here is the naphthalene ball. Right? Do you remember naphthalene ball? The white colored ball? Alright, so when you picked it in your hand, obviously it is hard, right? Of course. This is in line to solid particle, and when is the time to change its state into gas? So we can say it turns into gas because the naphthalene is directly converted into gaseous state or gaseous state. It is innate and become part of naphthalene bulb to automatically become gas. Yes, it is automatically. Without knowing how it disappears, and thing is most mystery about this is you cannot notice because without passing by into a liquid form. Therefore, we called it sublimation, wherein a transition of a substance directly solid to gas, change of state without the passing of liquid. So the hint is this is not the ordinary change of state, and basically it is rarely happen. So when we say rarely, it's panagsaon. Panalagsaon nga panghitabo. Yes, it is really happened with this kind of state of change. So we're done to the topic. Since we still have time, you can ask me now. Is there any concerns, clarifications regarding to our topic? Violent reactions. Did you learn something from today's discussion, class? Just be honest. Okay? Did you get it? Okay. Alright. So for the moment, I'll give you an assignment. Okay? Okay. I just want you to bring a piece of chalk and a water. And you need to be prepared for the next meeting because we will be having an experiment in regards to the topic that we are tackled now. So we will do an application for this true experiment, just like what I have said earlier. So that's it for now, and I'll dismiss you now, class. So goodbye, class, and keep safe always. Bye bye. Ciao.